Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us first understand the key concept here. Acidity of a compound is determined by the stability of its conjugate base. The more stable the conjugate base, the stronger, more acidic the acid. Moving on to the next step. Identify the acidic proton in cyclopentadiene. Cyclopentadiene has a sp3CH2 group, C5, flanked by 2 double bonds. The proton on this sp3 carbon is the one that is lost upon deprotonation. Moving on to the next step. Analyze the conjugate base. When cyclopentadiene loses a proton from the sp3 carbon, it forms the cyclopentadienide anion, C5H5. This carbanion has 6 pi electrons, 4 from the 2 double bonds plus 2 from the lone pair on the carbanion carbon, all delocalized over the 5-carbon ring. And for the final step, apply Huckel's rule. The cyclopentadienide anion is a planar, cyclic, fully conjugated system with 6 pi electrons, 4n plus 2 where n is equal to 1. This satisfies Huckel's rule for aromaticity, making the cyclopentadienide ion aromatic and exceptionally stable. Compare with cyclopentane. Deprotonation of cyclopentane gives a simple carbanion with no resonance stabilization or aromatic stabilization, making it far less stable. Hence, cyclopentane is a much weaker acid. Evaluate why other options fail. Option A. Conjugated double bonds alone do not explain exceptional acidity. Many conjugated dienes are not particularly acidic. Option B. Having both sp2 and sp3 carbons is a structural observation but does not by itself explain the high acidity. Option C. Cyclopentadiene is not entirely strain-free, and strain relief is not the primary reason for acidity. This option is irrelevant to acidity. Option D correctly identifies that the conjugate base, cyclopentadienide ion, is aromatic, 6 pi electrons, Huckel's rule satisfied, and therefore highly stable, which is the fundamental reason for the high acidity of cyclopentadiene. Therefore, the correct answer is D. Therefore, the correct answer is option D.